A very warm welcome if you've already been here. Welcome back. And if you've just joined us, then I'm happy you're here. We have an incredibly interesting keynote. And I would like to introduce myself quickly. I'm a writer and researcher at an Amsterdam-based lab called Affect Lab. And I will be guiding you through this session as a moderator. So we'll have first a talk for 45 minutes by Dr. Mavi Sanchez-Vives. And then after that, we'll have about 25 minutes for a question and answer session. So nice and rustig, we can really take our time and get into the subject. So for those of you who weren't here earlier, forgive me, there's some repetitions, but I would like to just introduce Mavi one more time. As a scientist, she studies how our brain represents the outside world and, of course, our body. She's the chief medical officer in her lab based in Barcelona called Virtual Bodyworks. Mavi experiments with virtual reality as a tool so convincing that the user feels fully embodied and present in a virtual environment. So bodies in this context are reconfigured rather to be present in a realm where they do not actually physically reside. And according to Mavi, here lies the potential to achieve not only a change of environment, but also a change of self. She works with case studies, specifically domestic abuse, which she explores to develop this concept of virtual embodiment into different forms of therapy, which perhaps she will take us through tonight in her talk. And she has many academic accolades. I could go through them all, but we would be here for a very long time, I warn you. I just want to say that she's the professor in the Department of Basic Psychology and co-director of the Event Lab at the University of Barcelona, and she's the editor-in-chief of the journal Frontiers in Systems Neuroscience. So please put your hands together for a warm welcome for Dr. Mavi Sanchez-Vives.
Thanks very much for the kind introduction, and it's a great pleasure for me to be here. So I'm going to talk to you about embodiment and body ownership in virtual reality, and I'm going to tell you why I started working on this. Actually, I'm a neuroscientist, and particularly I study how the cerebral cortex works, and I was working for some years on visual processing and visual perception. I was also interested in multisensory processing and using neuroscience techniques, electrophysiology and imaging and so on. And in 2001, I came across immersive virtual environments, and I was fascinated by the potential that I saw there in order to study perception, because it provides a tool which is very good for scientists, which is a completely controlled environment where you can do, all the sensory afferences, or most of it, that the subject is receiving, and therefore you can have a good quantification of how much of what they perceive comes from the outside world, which would be a virtual world, or from their own brain, or what we call bottom-up, top-down. And I thought it was a very good tool to study the brain. And so since then, I've been using virtual reality. A bit my focus has changed during these years. At the beginning, I was mostly interested in, let's say, in sensory perception, but in a few years, I concentrated in a specific perception, which is body perception. And this is what I will be telling you about today. So, virtual reality, that immersive virtual reality is what I'm going to be talking about, and is this reality that, like in Matrix, that some of you may recognize this, is a reality that is generated by a computer. And this reality is visual, but it also ideally is for all senses, like it displays ideally in all sensory systems, visual, auditory. Tactile is already a bit more difficult. For example, it's very difficult, let's say, to touch water, for example, but we can have some tactile correlations. There can be a smell, so it's also complicated how to generate and how to eliminate them, but there is also whole work there, and eventually also taste. But basically, as you all know, it's mostly visual and also sound and tactile, and very differently from a computer screen. It's a reality that surrounds you completely. But not only that, but you can move on it, and because your head is being tracked and your rotations and the position of your head is being tracked, what you see is going to be updated such that is correct. And therefore, and this is different from video 360 and so on, you can walk around an object and still is correct, or you can look under it and it still is correct. And this is going to be very important for body perception, because you are going to get all the correct visual motor and sensory motor and multisensory correlations. And therefore, this is going to enhance your, let's say, illusion that you are really there, and eventually that is really your body. So, as you can see in the slide, it tracks the head, eventually the limbs and the body. It's not necessary, as you know, to have a virtual reality experience, but if we want to have body representation, ideally it tracks your whole body, and so on. So this represents the idea that is multisensory. So for example, here we can simulate, for example, wind by having a tactile information delivered through a fan, for example, or one can wear vibrators, or there are different ways of delivering, for example, tactile. So this is an illustration. You can see here another big fan. And this is again from Matrix. And of course, if you were also in the round table before, when we talk about immersive virtual reality, and as it happened with the movie Matrix, many questions arise about the nature of reality, whether we live in, what is the nature of reality, is to what extent we live in a virtual reality, and so on. So it's something we can discuss later if you want. So a very interesting aspect of virtual reality, and you can see here, which these kids may be a bit exaggerated, I don't deny, but I just filmed it casually in a mall where they were giving this immersive virtual reality. Probably these kids are in some precipice or roller coaster or something. But I use it here to illustrate the point that an interesting aspect of it is that we respond to it as if it were real, in spite of the fact that we always know it's not real. So we know is generated by a computer, unless we would be sleeping and someone would put a helmet on us and we would wake up inside it, which is something that our colleague here, Mark, has been trying to do, to wake up in virtual reality. But other than that, you remember you put a helmet on or you put a head-mounted display, and therefore, since this is not the case, we know we are in virtual reality. And then why do we respond? Like if it's real, why do you jump back if there is a precipice? Or why do these kids scream? So in a way, we can think of it like illusions, right? So there are many sensory illusions. They've been studied for many years, for example, in the visual system. And if I point out at A and B, you may know this illusion. We know that they are the same color, but if I put the slide back, you still see them as white and grayish. So the fact that you know that they are identical doesn't prevent you from seeing them different. And you can think that this is a bit what happens with virtual reality. Our brains are wired and are very trained, and probably previously wired and then trained for many years with statistics of how reality is. And therefore, the brain is going to respond correctly for the given inputs. And the fact that your more frontal areas know that this is not real is not preventing you from responding. So, for example, you have here something called the pit room, which was used for a long time, or is still used. So if one asks people to get something in this chair, over here, people are going to normally walk around. People avoid walking through the middle, even when they know there is just the normal floor. But something tells you that you have to walk by the border, and especially if you put here, very carefully, you put some kind of edge, and you feel this, so now it's visual tactile that you get your feet. Notice the border is even more difficult that you walk across. So therefore, this is an illustration that even when we know it's a cartoon or we are going to respond, we will jump back. If something comes against us, we are going to try to avoid it. Or if an avatar smiles at you, even if you know it's a cartoon, you are going normally to smile back. So there is an interaction, and this is something important to keep in mind. So what do we use it for? So we have this tool, let's call it like that, where we can have a complete reality that is being generated digitally. And everyone, well, the first idea and probably the most extended use is computer games that one can use immersively. And this is true. This is a huge, huge area. And entertainment, but not only this. So in general, we can think of it that is a reality that can allow us to expand our experiences. And this is going, well, eventually we are going to learn from it, or our brain is going to be modeled. This is what we do when we have experiences. Somehow it's going to affect us the same way that reality affects us, or similarly. So I will go progressively. First, there is a place illusion. So what can we do in virtual reality? So as I said, the most common use, let's say, is games. And then if you get any demo from a new hardware, piece of hardware, a head-mounted display, you may have the illusion of being somewhere. So there is place illusion that can be achieved if it's multisensory, or with 360 video, you can have the illusion that you are at the top of the Everest, or you are sailing the sea, or you are in Mars, or in the spatial station looking down at Earth. So you can have this illusion that you are somewhere. This can be very nice and very pleasant. And you can also have experiences, right? So another common demo is being in a roller coaster or flying also. I will show one of these contraptions to fly. So we can have some experiences, we can have the illusion that we are in places, and even we can use this for training. So, for example, it was also mentioned in the roundtable before, the fact that actually reconstructions of Baghdad in virtual reality were used in order to learn to navigate Baghdad. This would be an issue of discussion, to what extent the maps that are formed in our brain by navigating in virtual reality are good. So it's necessary also to have some kind of movement and sensory motor correlations while we navigate to make proper maps. But for example, the fact that we are in a place can be used for us to learn this place. This was mentioned before because these kind of environments were used also later to treat post-traumatic stress disorder. But this is not why I have it here, but I have it here for the fact that we can learn places, we can get to know, and maybe our brain can generate a map of a virtual place. Okay, but now we go one step more. So we are social beings, and generally we associate virtual reality, or people do associate it with isolation. So the fact that someone goes into a virtual reality, they put a head-mounted display, they get disconnected from the people around, and then there is this concern about to what extent this is going to cause too much isolation. No? And probably there is a part of truth in it. Of course, there will be advantages in this sense in augmented reality, because one can be in the same space as the people around. But the fact, we need to take into account that virtual environments, they can be populated. So therefore, there can be other avatars, and these avatars, they can be controlled, for example, by artificial intelligence, or they can represent other people. So not necessarily the fact that someone gets isolated from the ones around means that virtual reality cannot be actually a very interesting tool also for having social experiences and for having social interaction. And I can imagine very well how old people, for example, when we think about VR, everyone thinks of young people, but actually old people like very much virtual reality. And I think that someone that has difficulties to move, for example, can be very pleasant to be in shared environments, even if they are virtual. So you can meet with other people, or you can attend a populated class, or you can use it for training. And there are many, people working on different applications for example, training to speak in public, or training to do work interviews, or for doctors to train to get to talk to patients or to deliver news in a correct way, and so on. So not only they are social and populated, but one can have an environment, or we can go to work meetings, business meetings without traveling. We could share the space with other people situated far away, and we could share a space and have a meeting and avoid the traveling. So it's more immersive in that sense that being on Skype and so on. So therefore, there is the social component to it. And this is an illustration where this is an environment. And you can see how, for example, these avatars are not very realistic. And this is actually where I want to go next, which is that so far we've talked about realistic, let's say, virtual environment. So we've talked about being on the Everest, or being sailing, or being in realistic places. However, something that actually virtual reality can offer to us, and this is interesting also because I think some of you are artists and so on, is the fact that VR doesn't need to be realistic. So we can have experiences similar to dreams. So there are no limits, in the sense that we are not limited by the physics, and we are not limited by our bodies, for example. And if you think of dreams, in dreams we can do impossible things, like, for example, flying. And this can be done. Of course, one needs a bit of help if you are trying to have more the physical experience, not only the visual, but the whole body position, vibrations, and so on. But one can get this illusion of flying, for example. And actually, this is part of the interest of the media, that you can do things that you cannot do in real life. And actually, I try, when I design studies in virtual reality, I try to take advantage of the media and try to do the things that are impossible. It doesn't mean we do fantastic environments, but it's good to use it in a way that you can do things, take advantage of things that you cannot do in the real world. This is a better way of using it. So in dreams, often The environments, well, of course, they can be fantastic, and this can generate different pieces of art, like this one here, where one can have interesting interactions with environment, for example, or create between different people a piece of art. This one, I took this photograph in the World Forum in Crans, Montana, in the World VR Forum, and this was an interesting piece where people could contribute to create and so on. So there can be this kind of fantastic or non-realistic aspect to it. But an aspect that is very interesting in dreams also is the fact that we are not tied up to our bodies. And this is what I'm going to talk to you about for the rest of the talk. So we could say, if it can be imagined, basically it could be done in VR, and one is not to be tied up to our own bodies. So the experiences in dreams, probably you have experience where in a dream you may be someone and all of a sudden you are someone else, or the same happens with other people, they can get transformed. And actually this can be done, or one can try to do them in VR. So around 2004, I told you I was studying, I was interested in the use of VR for perception and so on, and I came across an article on the rubber arm illusion that was also discussed earlier today, and I came across a paper where they describe this illusion that you could feel a rubber arm as your own if you had these visotactile correlations in this rubber arm. And then I discussed this with Meles later. We thought, well, I mean, could we do this, replicate this illusion in virtual reality? And this is what we did. And then what you can see here is this was some of our first approaches. In this case, it was with a large screen for immersion. It's stereoscopic and so on, but it's not with a head-mounted display, but in a very large screen. And there is some visotactile correlations, and we compare in our study against non-correlations, as you can see here. So here there is temporal correlation and a spatial correlation. So you see a ball touches your hand, and you feel a ball touching your hand in the same location. While here, you don't, the vision and the tactile stimulation, they don't go along with each other. And what we found is that in this case, where people would see, they would see this 3D arm coming out of their shoulder. They were with their arm like this. And we found that the illusion of ownership over this arm was the same that people had reported for a rubber hand. So, okay, this works. We can have a virtual hand that can feel as your own hand. And how do you know this? How do we measure it? Well, first of all, when it's an illusion, you always have to ask the person. So there is one aspect which is subjective, but then you can measure it in different ways. So for example, we measure where people feel their hand to be, and they have to point out to it, and then you can measure whether it coincides with the position of the real hand or the virtual hand, so you get a measure of the proprioceptive illusion. Or you can measure whether there is a response if the hand gets threatened, or whether there is muscle activity if the virtual hand moves, and so on. So we always try to have some battery of objective measures such that we try to capture this illusion. And most interesting is when we find, as it's the case, a good correlation between the subjective and the objective. So we can measure to what extent people feel that this is their part of the body. And then at the time, there was different studies with rubber arms and so on with visotactile correlations. And then we tried visomotor correlations. So what happened if instead of the visotactile, we just had a hand moving and a glove that measures this movement, and then the virtual hand that you see it here flat, but the person, the user, is seeing it 3D. So So what happens if there is this visuomotor correlation versus asynchronous? And again, we did a study, and we found that with visuomotor, we got, again, very similar level of ownership of that arm. So this gave us this information. Okay, if there is this sensory correlations, the brain generates an illusion that this is part of you, is part of your body, with the advantage that this is virtual. So the rubber hand illusion, which I haven't shown because it was before, but basically it's the same thing but with a rubber hand. Of course, the rubber hand is a physical object, and you cannot transform it, you cannot make it bigger, change the color, make it move. However, with a virtual hand, you can do all this, and it gives you a lot of possibilities, and this is what we've been doing for several years, actually. And eventually, we applied these concepts to the whole body. And what you can see here, I'm going to stop it there, is a very important cue for your brain, which is the first-person perspective, which is what happens when you look down. When you look down, unless you play some trick on someone or something like that, when you look down systematically your whole life, you perceive your own body. It can be the body of a child or the body of an adult, but this is what you see. And the first-person perspective is a very important cue for the brain that this is my body. Okay, so this is something you have here, but also you have all these correlations. And also to enhance these correlations, you can see yourself reflected in a mirror, and still there are more correlations. So all this information that is coming to your brain is saying, look, I see my body from a first-person perspective. It moves when I move. I see it moving in the reflection. Well, certainly this is my body. So this is a very strong signal, and the brain is going to be very convinced, and we can test this. How convinced and how flexible this is going to be. So for several years, we have been measuring how much you can manipulate this body, how much you can transform it, how much it can be, let's say, far away from your real body, in position, very detailed, maybe even boring things, but we wanted to collect all this information to have a full understanding of what's going on up to a point. So one of the experiences that we did was, well, let's see how much can I distort this body and still keep having a feeling of ownership. So in this experiment, there was this visotactile correlation. The person is touching this green little carpet, and they feel the touch, and they move, and they see this hand moving and touching this thing in correlation, and then the arm starts elongating and getting longer and longer. And we measured in different lengths to what extent still it felt as your own arm. And actually, you can go even 4 times the length. And there is a small decay in the ownership, but actually, in spite of the fact that the body becomes asymmetric, which is also something strange, but still, you can keep a pretty high sense of ownership with 2 times the length of your arm, only one arm. So this was one of the aspects we saw. Wow, this is very flexible. We can use a much longer arm. Still, you can feel that is your own arm. And then you can try different bodies. I will show examples later during the talk where you can feel ownership over the body of someone of different gender, different age, different race. There is no much problem with this as far as some rules are followed up. So if you bump onto something and the other arm doesn't bump onto something, this may break the illusion. Or, as I showed before, all these asynchronous conditions, if there is asynchrony, there are things that can break the illusion all of a sudden. So if you go from synchronous to asynchronous, there is a degree of tolerance, but then the illusion can just vanish, right? So, but if there is consistencies, then it can keep going through different modifications. So here, this is an environment. I put it here just to illustrate the fact that the bodies can be non-realistic. In this case, was another study of a shared environment, and there was a whole experience where you carried out tasks with other people. I won't go into the details of why this was done, but in this case, for example, there is this kind of anthropomorphic but non-realistic characters, and this is no problem at all for embodiment. So you can feel completely that is your body and have a number of reactions to that. So in this case, is this shared environment, and then people have to collaborate to carry out certain tasks. Sorry. So embodiment is defined as the sense where the person locates him or herself inside the physical boundaries of their bodies, and therefore something that I thought you may find interesting also is the fact that one can have, therefore, out-of-the-body experiences. And this is very interesting because out-of-the-body experiences are experienced by some people, but it's very difficult to do this at will. And then some people have it because they have some problem in the brain. How is this experience? We have all heard about this, right? Like you can float over your body and see yourself from the ceiling and so on. So actually this was done in the lab, and this I was telling you before, look, not all the virtual reality has to be completely realistic. So for example, we can do this that obviously we cannot do in the real life. So what we did here was there was this person sitting, and then what you can see here in yellow is that they feel some correlations, some balls are touching their body and they feel them, and then they move the legs. You can see these yellow things here. They move the legs, so their body is there. And then eventually in one of the groups, in the experimental group, they start leaving their point of view and they start floating over their bodies. And then they can go all the way up to the ceiling, and they feel their body down there, and now they don't feel the tactile, they don't feel even if they move, they don't control the body anymore. And therefore they have a disconnection. So on the one hand, it's a weird experience, and it's interesting for how it feels per se. But you may wonder why did we use it for, and actually this was used not by me, but in our group. This was used in a study of fear of death, and interestingly, and consistently in 2 studies, the people had less fear of death after having such an experience. So there was some change in them by having this kind of out-of-the-body experience. It's not precisely a spiritual experience, but something is out of the body and keeps living. So somehow it triggered this idea that death must be like this, I suppose. And there was a decrease in the fear of death. And also people had some changes in how they evaluated, they were more worried about global issues and so on. So these kind of experiences, they can give you some new vision, new experience that can make some change in you. Of course, one can wonder how long does this last? One can do studies 1 week later, 2 weeks later. It's not always possible to do these longitudinal studies, but after the experience, this is a significant change. So we all have this illusion, that the self is some kind of intangible or ethereal thing which is separated from the body. And however, we see how important the body is. The perception of the body is very important for the development of the sense of the self. Is what gives us tangible unity and borders and limits and so on. And also, what we see in the studies that I will show you next is that the body that we feel as our own body, that can be virtual, is going to have an effect on us. and it's going to have an effect that many times we can measure. So it's going to have an impact in our physiology. For example, we can measure responses. We can actually modulate pain thresholds and so on. So it's physiological. It's going to have an impact in how we behave. So the aspect of the body is going to make people behave slightly differently. And it can have cognitive changes. I will illustrate also with an example. So actually, even when we think, we are very, in a way, the self is sort of disconnected from the body in a way, no? Actually, it's very determined by how our body is. And virtual reality gives us a good experimental frame to explore this. So let's imagine, for example, that you put a head-mounted display and you are a child. And then you look down, and then the floor is closer because you are shorter. And you look at your hands, and you can see how they are roundish. And the things around, they look bigger. And then this mother figure walks in, and you have to look up, which is also a very strong cue for your brain. If you look up, you are small, and then you have a different sensation of how you are going to relate to this other person, right? So you have to look up, and then this person talks to you and gives you instructions or complains that the room is untidy or whatever. And then you can see yourself reflected in the mirror, and you move, and this body moves. And this was done in the lab, and Domna Banaku, she measured how much people would estimate the size of objects after being for some minutes in this smaller body. And interestingly, after this experience, there is an immediate overestimation, and I'm sorry because I didn't include the graph, but this is actually an article in the Proceedings of the National Academy of Sciences. So people immediately overestimated the size. And this is very interesting because actually the size of our body, and indeed the shape of the body, is going to affect how we process the external world. So we are going to perceive things larger because our body is smaller. But this is something that can be evoked in minutes. So therefore, we have this kind of recalibration of the outside world, which is based on the dimensions of our own body. And this is very interesting. It's a cognitive effect. You can measure it. And it's a direct effect of having a body of a different size. And actually, there is another group, which is a shrunk adult. I didn't want to bring graphs and too much data, but it's different to be a shrunk adult than a child. So you overestimate more as a child. Okay, so therefore, your body is going to have a cognitive impact in how you perceive the outside world. Dimensions can be one of these aspects. So, or how we perceive a space. So how about if we change race? So, see how I'm doing time. Okay, so we can also easily embody a body of a different race. In this case, we're Caucasians in a black body, and there is no problem. It's very fast, the induction of ownership. And actually, in some group, there's been several studies in the lab. And in one of the groups, actually, they came for several days, and they did actually a Tai Chi class in their new black body. And of course, we do these movements in order to enhance the identification with the body. And they did this for several days. And in all the groups that have been studied by us, but also other people in other countries, they have studied with videos and so on, there is a consistent effect, which is a decrease in the racial bias, in the implicit racial bias. And this is quite consistent across studies. So the fact that one gets this internalization and identification with this a new body, it causes this decrease in the implicit racial bias. And what is the implicit racial bias? So is this kind of measures, they are quite validated tests where you have to respond very fast and associate values with race or with gender or with different religions and so on, and then it's very fast, and then there tend to be biases, which are these biases that we are not very aware of, but somehow they are there. So this is the effect. So therefore, we can say, well, I showed before that our body is going to influence how we process space, but our body is going to influence also how we process the others. So we are going to feel closer to the ones that are, let's say, more similar to us. So I told you about physiological effects. And actually, for several years also, we've done measures of something which is very physiological, which is measuring pain threshold in healthy people. We did different studies to see whether we could manipulate. So pain threshold is measured with a system that is used in hospitals that basically you have to stop when you feel that a stimulus becomes painful, which is heat stimulus. And this is used as a standard measure to detect pain threshold. And we saw that, and this is very illustrative, that the color of our skin is going to modulate the pain threshold. So as somehow one can imagine, if your arm is very red and it looks well, red we associate it to inflammation, pain, and so on, lesions. So if the arm is red, there is going to be a bit lower pain threshold, which means that it's a bit easier to get the pain than if you have other colors. And it's not the red per se, because this is a control where there is red color, but is now outside the arm here. And this red color is not going to affect at all the pain threshold, because it's more painful when it's your arm, not when there is a spot next to the arm. So therefore, it's a nice measure that the aspect modulates how we perceive incoming inputs. Or we also played around with transparency, and this is, of course, something you can never do in the real world. So, of course, with this one, you could say, okay, you can project lights of different colors on your arm and do this experiment. But, for example, transparency is something that you can only explore if you are using this kind of virtual reality. So we wanted to see whether making the arm transparent, how it would affect the pain threshold, and it also modulates it. So the more transparent it is, the lower your pain threshold. And I have a whole theory about this, but if someone is interested, I can tell you later. So therefore, this is an example of a physiological modulation. And of course, one wonders, okay, I mean, I study pain threshold, but what is interesting is to try to modulate pain in people with real pain, not with pain that we deliver. And we are working on this with patients with chronic pain. Actually, my institute is in a hospital, so we have access to the pain unit and so on. And we are working with some success and we are studying which types of pain are more amenable for this kind of modulation. So we have published some papers on pain on chronic patients, chronic pain. So almost the last part is that we wanted to use this. We think is very powerful. So it's a technique. I think I've given you examples how our body is going to has this effect. So therefore, we have a powerful technique there. And we focus in a project that we started in 2010, actually, on a problem which is domestic violence. And domestic violence is unfortunately quite prevalent all over the world. This is data from the World Health Organization. And they calculate 1 in 3 women have some kind of physical or sexual violence by a partner, and so on in their lives. So if you look at the numbers, actually there is a bit of difference across the world, but not so much. So like the lowest is 23.2%, and the highest is 37.7%. So it's something that is quite spread all over the world. And then the question was the following. So violent behavior is commonly associated to low empathy. So we thought, well, if you can get into the body of someone else, maybe you can increase your empathy for this person. So could we enhance empathy through VR? And specifically, could we enhance empathy of aggressors for a victim? Could we help to get this, if people, not everyone we can all imagine, how it feels to be someone else, but not everyone has the same capability for this imagination. And the advantage of a head-mounted display is that you don't need to make this effort, just they can give it to you, and then maybe it can compensate these people that have more difficulty for this. So we created an environment based on real stories and so on, where there was a woman. This is the first-person perspective. This woman does a number of exercises in front of a mirror because there is some instructions coming from a radio. And then there is this guy that enters the apartment, and he has this speech against her, which is humiliating and so on. He complains that her aspect is not good. I didn't put the video. He becomes closer. There is never a physical violence, but he eventually hits this phone. He complains he talks too much on the phone and breaks the phone against the floor. And he gets progressively closer, which is invading the space, and more threatening, getting closer and closer. He's taller, and eventually it's easy that gets so close that people put their hands like this. There is also a bit of interaction. So there is like, because the head is struck, when there is, the person looks away, he screams, look at me. Or if the person speaks, one can trigger, the guy says, shut up, and so on. So there is a bit of interaction. So we designed this, and we said, well, let's try it with men, with control men, that, of course, they know this is virtual. Maybe they don't care because, it's a cartoon and a guy that screams at you, which is much less to what happens in any video game. So it's possible that there is no effect at all. So we tried this in different groups of men, changing perspective, first person, third person, like systematic scientific studies. And then we interviewed and we measured different physiological and so on measures. And we saw that actually men, they knew it was virtual, but as I said at the beginning, one responds to it. And this response can be emotional, so they were really bothered by this guy speaking to them. So I forgot to tell you, of course, they went into a feminine body, so they went there. They were a woman, they moved, they felt this body of the woman as own. Then this guy entered and offended them and got very close and so on. And then they were very bothered by this. They found it like unbearably humiliating, aggressive, because men are, I learned, extremely bothered when their peripersonal space is invaded and they have to look up. This was perceived extremely aggressive, and so they were bothered by it. So we thought, okay, maybe it can be used for rehabilitation of aggressors of domestic violence. And then we started this in a collaboration with the I'm being told that the time is up, but I have to finish the story. So I'll finish this. Then we started a collaboration with the Justice Department of Catalonia, and they run the rehabilitation courses for domestic violence aggressors. And we started using it in these rehabilitation courses, actually in collaboration with their psychologists, the teams of psychologists that run the rehabilitation and so on. And since then, we have this ongoing collaboration. Now they are using it also in prisons, and we are expanding on this, on how to give this training on empathy with the victims. We have seen, I didn't tell you, in the control men, actually we found, apart from that they were very bothered by this, but also they decreased their bias, their gender bias, so somehow they identify themselves better with women. And in the aggressors, we did a number of measures and studies, but something that we find very interesting is that in people with violent behavior, there is quite a consistent reports by different groups that there is a deficit in emotion recognition. And, well, emotion recognition is very linked to empathy, actually. And what we have found also already in 2 studies is that there is an improvement in the emotion recognition in the faces of women. So this is a very interesting measure. And there are other aspects to it, like a more explicit reports on the fact that they understand better situations. Like, for example, some people consider that if there is no physical violence, this is really not violence. But actually, after going through these situations, there is often this explicit recognition of, well, I understand that this is very violent and so on, and well, more explicit details. All right, so this can be a useful tool. Also, one can learn to respond non-violently to certain stimuli. So it can be used with that objective. And as I said, we continue this collaboration. So VR, therefore, it allows us to take the perspective of others. And this has changes which are, some of them are explicit. It's like, well, I understand what it is to be a woman, or what it is to be of this other religion or race and so on, because of how people respond to it. So this gives you an understanding which is explicit, but also we observe these changes which are implicit, like a decreased bias or a change in emotion recognition. And sometimes this implicit is very automatic, is not so rational, is something that you learn automatically, but is very important as well to change attitude. Okay, so finally, to finish, I will tell you that we now have the technological capability. Our team has generated these very nice avatars after scanning people, so they can have realistic avatars. This is the philosopher Daniel Dennett in the lab, and this was his avatar, and this allows also to not only to be in the body of someone else, but also you can be outside your body and even see yourself from the outside, and even keep a conversation with yourself from the outside. And this is very interesting because I'm about to finish. Well, because sometimes taking a distance from yourself, it can be very revealing. You can even, what people actually do in this paradigm in the lab is that they come and we tell them, well, you can tell if you have some problem. People talk about their problem, then they change perspective and they go out from themselves. They hear the replay, they see themselves. They hear their problem, they answer to their problem, they make comments, they allow to have a different perspective of this problem. Actually, this is Sigmund Freud. And then the voice, only the voice is changed, so they hear then Sigmund Freud, and they can switch back and forth, having their perspective from the listener or from their self, and from the listener from themselves, and they can maintain in this way a conversation with themselves, and they can give advice to themselves. And people find this quite useful because they see their problems under a different light. And I think, therefore, this is also a very interesting aspect. And these are some articles, also scientific articles about this. And this is also another aspect of virtual reality. So therefore, to finish, is not only games that we can do with this, but we can use it in many, many different ways of applications. But some of them can use embodiment either for treating pain, but also to understand better other people and even ourselves. So that's it. Thanks.
Thank you again, Mavi, for that very thought-provoking talk. I would like to just kick off with a question I was thinking this morning when I woke up. I had quite a bad head cold the last 2 days, quite a lot of pain in my neck, behind my ears. I wasn't feeling great, you know, and I knew tonight I would see you and I had to moderate this talk. I thought, wouldn't it be wonderful if I could be virtually embodied as a very healthy person right now? And maybe I could even change how I feel, you know? And I wondered then to you, can it work this way? Because you've shown us how it may work the other way around. But could I feel as a physically pained body through virtual embodiment the opposite, that I might feel better, less pain?
Yeah, well, so there is no magic, okay? So if one has a cold, the cold is there. However, I think actors know very well that well, the attitude, the position of your body, the whole emotion that is linked to your body position, right, is going to have an effect on you. So there is this old discussion of, do you cry because you are sad, or are you sad because you are crying? So if you are crying and you feel the tears coming down, immediately you become sad. And this is something that actors used to know, that the behavior also contributes to generate the emotion. So in a way, there is some of this. So if your body looks healthier, stronger, sometimes even if it looks stronger, it can even have an effect on what you can do. So your aspect has an effect in how you respond and how you feel. But if you have a cold, it's not going to cure the cold.
Okay, and then before I open it up to the audience again, I had a slightly more complicated question. I grew up in the 1970s and 80s in South Africa during apartheid, so severe racial segregation, and you know, we all know that South Africa has a history of very tense race relations. So I was very interested and extremely curious about your work in racial bias, the idea of inhabiting the body of the other, and especially the black body. And as a white person, I'm extremely sensitive to this idea of, you know, the privilege of being able to somehow inhabit a black body. That said, I'm also really cognizant of centuries and centuries of violence and intergenerational trauma on the black body, conditioned through social conditions, systematic centuries of slavery, all sorts of aspects that condition the black body in a way that, as a white person, I would never, ever come to experience, right? So I was troubled a little bit by this moment in your talk, the idea that I could somehow, in a virtual reality moment, feel what it was like to be a black body doing Tai Chi. I must say I wasn't convinced. Maybe you could talk a little into this point, give me some context. I would love to be able to understand more.
Yeah, well, so there is a whole aspect to it that, of course, you cannot inherit this. You have the culture, the whole thing. But there is some aspect which is simple, is basic, is automatic, which is, you know, now this body is mine. So there is some automatic aspect to it, which now your in-groups are the people with a black body, for example, in the virtual environment, and there is an identification. So there is, of course, I wouldn't claim that there is a whole, although, of course, your more conscious part knows all the history or part of it, and there is a whole set of associations that you may make to this body. This I don't know in depth. Some people work more specifically on this racial bias and so on, but there is some automatic aspect in which you get closer to this body. And actually this happens sometimes. It has been measured also with people that have a partner which is from a different race, for example, and immediately you get more associated. So for example, if there is one way to measure empathy, which is how much you respond to the pain inflicted in someone else. For example, with a needle, no? If someone gets like a blood test, you see a needle going through their skin and then you feel like this. And it's known that you feel this is more stronger to people that are similar to you. So, but if you are very identified with another race, for example, because your partner is of that race, then it changes, right? So it's a similar effect in the sense you get more identified. And also an interesting aspect, in virtual reality, very often there is no studies of mid-term or long-term effects. So in this case, this was still 1 week after the experience, which is one of the few data that we have after an interval, because many of these effects, there is an open question, which is how long do they last? And this lasted 1 week before still the racial bias was decreased. So there is some automatic effect, and of course one could elaborate and study it in much more detail. Yeah.
Okay. I'd like to open it up to the floor, and then in between I may ask another question. But does someone have a question for Mavi? In the center? If you could just speak into the little black section of the blue box, please. Thank you.
Yeah, hi. Thanks for a fascinating talk. A bit of a follow-up question. I'm curious how these changes that seem to happen mostly in the kind of implicit, non-conscious elements, how do they interact with conscious change? So, for example, to take this racial bias experiments, would the people that went through this change usually have a kind of conscious idea of, wow, I feel a little bit consciously different in how I experience black bodies, or would they say it's exactly the same, but the effect would still be there in implicit biases? And secondly, would someone that, for example, has a strong personal narrative of being very, very tolerant and non-racist or explicitly racist, would they, or could you speculate if it wasn't part of the experiment, would they experience this process differently?
Yeah, that's very interesting. So in which, to what extent these changes translate into changes in behavior. So we don't really have good measures of this. For example, we haven't tried to recruit like racist people. There is a lot of research that can be done. So I cannot answer to that. So I know that if you try to detect how is their attitude, it changes in the way that we measure, but we don't have any measure of how it translates, for example, in their real life. So it would require to do a follow-up with people with different degrees of explicit racist behavior, which, by the way, in Spain is not a good country for this, because there hasn't been much black population. So, it's very different to do it in the US, for example, where there is a whole cultural issue with this and so on. So I cannot answer to what extent this gets translated into a change in behavior.
But
it's a very important aspect. Yeah.
Is there any experiment where the kind of identity that people come in with affects the implicit or explicit effect of the VR in any way?
Well, there is a lot of, of course, the implicit is very related to the explicit attitudes, right? So this is known. So in that sense, yes. But we haven't done any kind of follow-up on whether you have a change in the implicit and then you have a change in behavior. This I cannot answer, but it's known that the implicit is very associated, yeah.
Okay. Thank you. Just over there, thank you.
Yes, I had a question about the body identification, and then when...
Sorry, I couldn't hear.
Wait, can you understand me now? Yeah, I had a question about the body identification where sort of, the arm becomes longer and these things. And I've also read that the body or the human brain can also embody bodies that are specifically non-humans, like for example by putting sensors on certain muscles that you can operate wings, extra wings on your back, or even embody sort of body shapes that are very non-human, such as a flying vehicle or sort of other, even a car on wheels or something. Does your research extend into those type of territories?
Thank you.
Well, we had felt the temptation of going into this, you can have very strange bodies. I cannot answer about this. I haven't explored this. Of course, you can incorporate other parts, or for example, the very original studies by Jaron Lanier, who came up with the definition of the term of virtual reality. He explored for moving some kind of lobster body, and then eventually you can learn. So I'm sure one can learn to move a fourth arm, a third, a fourth arm, maybe a fifth arm, and maybe even if like Mark, if one wears this continuously, maybe even some areas in your motor cortex specialize on that. This is possible, but we haven't done it. But I find it feasible. So if you, and what I have done studies of brain-computer interface used to move a body, and we have an article now in Journal of Physiology on how to induce agency. So I haven't talked about agency, but the control of the virtual body. So we have controlled the virtual body through the brain-computer interface. And I think if through a brain-computer interface, for example, you would control different extended body with more legs, or like a octopus body or whatever, I think eventually one could generate areas specialized in moving these parts. So I find it feasible. From a neuroscientific perspective, yes, you would need to give this command and then have a feedback. Have a visual feedback that leg is moving, and even you would feel something in correlation. And if you do this again and again, you could get trained into doing that. I think it's perfectly feasible.
It's a fascinating post-human future. Yes.
Wait, let me. Yeah. Well, I hear, but I have it. Oh.
Oh, wow.
First of all, thank you very much for your very interesting talk. When I listened to you, somehow it reminded me to very old ancient techniques of how to transform life through mental control, like the ancient yogi culture does it, or meditation techniques of the Buddhists, and neuroscientists are doing research also on this topic and try to understand how to control your mind, control the construction of reality, the relation to reality and to others, which somehow for me seems to be a more a cheaper way of having access and transforming our reality. But maybe you can explain what is the difference, or what can offer virtual reality techniques to in this transformation process in comparison to ancient mind control techniques.
Yeah, so first of all, from the neuroscience perspective, a lot of the taboo about studying these things has vanished in the last couple of, or I would say 1 decade maybe. So somehow no serious brain scientist a couple of decades ago would say they were going to study consciousness, for example, because it sounded not very serious, and now it's a common topic, so it can be said study consciousness, or for example, do brain studies of meditators. So now I wouldn't say it's mainstream, but it's very well accepted, and it was really in the 80s and 90s still quite unexistent in serious, let's say, in neuroscience. No? So, so now there is an openness to study, for example, how are the brain patterns in people that do meditation, and studies of consciousness and so on. So, but what can VR bring on top of that? So, I think, as you say, some of this experience could eventually be evoked. And I was saying before, people can put themselves, imagine how it is to be someone else, but not everybody can. So not everybody has the same capability of let's say, imagination or take someone else's perspective. So in that sense, what it brings is that you can do these things without much effort, which can be good or can be bad, but it can be the same for everybody in the sense that also you know what the other one is seeing, is experiencing, and so on. So I don't mean that not making mental effort is good per se, but you can facilitate this. So, for example, people can have out-of-the-body experiences, and I know people that can even induce them at will to have an out-of-the-body experience. Or as someone was asking before, lucid dreams have some things in common. But of course, it's difficult to have lucid dreams at will. You don't know what you are going to see. So here you can know exactly what you are going to experience, or you can decide it, or you can deliver it to people. So basically, it's just to make it accessible without much effort.
We have time for one more question. Jan?
Well, I was thinking about maybe people with anorexia already having this kind of virtual experience in real physical life. And I don't know if you ever worked with people with anorexia, because they have already a false image of their own bodies.
This subject has come up in the lab many times, and actually we even had an environment at some point. I have to say we never got funded. We applied a couple of times for projects for this type of disorders, and then we never developed it. So we started even a collaboration with people that were doing therapy on anorexia. So it's a very interesting topic because there is the perception of the body is damaged, so it's perceived as fat when it's not, and then one could think of ways of trying to help to correct this with VR. Also, of course, as you have seen, one could do a proper scanning of the body. You can walk around your body. You can see yourself from the outside. So there are a number of strategies that one could think maybe we can find a way to work on this, or for the therapists to use it to work on it. but we have never actually done this. Yeah.
Okay, I think, do we still have time? No, that's a big stop sign. Okay. Thank you so much to you, the audience, for your wonderful questions, and to Mavi. Thank you so much.
Thanks.